So, firstly, about the front side, do you guys need it to enlarge or is it okay? Zoom in or not? It looks fine. All right. So basically, so I'm currently using my own laptop, so the screen is a little bit larger than usual. Um, So what have I done? So make sure that when you're doing part A and part B, make sure you have a different copy. Okay, so that the bug-free version in A doesn't get impacted. Okay, in part B. So make sure to get a separate copy. And here, what I'm doing is that okay. These address style, year built, those are the old attributes, right? But now let's say I want to get just like what I discussed a little bit earlier. We want to know how many people are there on a particular floor, and we want to know whether the water is on in the particular floor, and whether the lights are on in the particular floor. So by default, I'm gonna set the attributes to be false for those. Yeah, let me also make it a little bit larger. So essentially, this is a loop that for each floor. Okay, so let's say we have three floors, then I would want the index to be 1, 2, 3. Okay, so it's running from one to number of floors plus one as a variable, and then basically for each floor, I'm gonna set self dot people floor one, people floor two, people three, but it's not gonna be used as a string, so that's not gonna be directly, well, assigned like this right here. So what I'm doing is this is a feature that's called the set attribute. Okay, so and then later when you want to update it, you can do get attribute. So if you want to also do a loop, or well, in general, it's going to do the same thing as before. So basically, it's going to be self dot people floor one, people floor two, people floor three, all the way up to people floor nine floors that you have. Okay, so if you were 10, then it's just gonna be ended with 10. So this is a way that you can do in a loop. Okay, so that's something I find interesting to share. Also, make sure to think about this, and of course, if there are things that you want to try, then you can always ask a large language model for them to give you some ideas, and then you can try on your own. Okay, so that's one thing I like to mention. That may make your house class a little bit more interesting. Okay, and also making it more systematic. And if you only call the variables, it's going to be the same idea. Okay, so let's say my house one has three floors, it's a townhouse. My house two is a condo with two floors. Then indeed, I can do my house one dot people floor three. That will call that's a zero default number there. Okay, originally there was zero throughout the floors. And then that's gonna print me a zero. And then I assign for the house two, second floor there were three, then it's gonna print me three. That's you can assign numbers and print them just like the global variables, just like we have introduced earlier. It's just that okay, it's a variable. So for a condo with two floors, you don't have a people floor three that's defined in the in that object. Okay, so in that instance, so it's not universal. It's really up to the number of floors that you have. So just make sure that you are aware. Okay, and then possibly then you may want to give something like okay. I have only two floors, then you may want to write some like a returning error message for you asking for a incorrect floor number, right? So those are the things you can set it up in your own house. That makes sense. So yeah, basically what we have done just now is to systematically do those assign those or initialize those global variables. Okay, so indeed they're global, so you can call them. Yeah. So um right. Right. One more thing. Okay, so so let me just put it as a comment. So do get at attr. Okay, so set attribute is a way that you do not have to do self dot people floor one, two, three. But then those are done in a loop, right? And then if you want to also, let's say, get the function, okay? If you want to get a method to change the data in a particular floor, then what you do is to use that get attribute. So get that attribute and then assign the value. So it's just a slightly different function, okay? But the utilization is same. All right. Uh, I'm gonna let this sink in for a few more minutes, and then I'm gonna jump into section 8. Okay, lecture 8. Let me stop the share here, and let's jump to. Okay, so lecture 8. So a little bit more involved topics in object-oriented programming. So although we are now talking a little bit more about other possibilities, okay, in object-oriented programming, but basically we are indeed actually doing overviews for. So now we see we only talk a little bit about data structure in this section, okay, and then we end the majority of the discussion for OOP. So they are sort of like touching the surface of each big topics. Okay, for deeper understanding of these topics, I would recommend you guys to go into computer science focused courses that are more dedicated to these topics. But okay, so in terms of object-oriented programming, what do we need from here? So object-oriented programming is a system of thinking for treating things as objects. So basically, that the object here is essentially anything that you can code up to. Okay, so whatever thing that you want to code up, you can treat it as an object. That's and then there will be attributes and operations that you can perform on these objects. Okay, so the operations are going to be called the methods. And indeed, within current course, most of the topics within this circle will be touched. Okay, so we actually have covered an object. Okay, and then basically we define the class, and then the attributes and the methods are what we emphasized from last time. Okay, and then these are certain things that we're going to talk about in today's class. So inheritance. Okay, so that's something about making like a subclass based on your current class. Okay, so that make it a little bit more specific and more interesting. So that's but you still can inherit attributes and methods from before. So that's what we're going to talk about mostly for today. And then abstraction. That's basically you are treating whatever that you try to implement as a function as like a black box, right? You only specify what the inputs are, what the outputs are, but everything within the black box are hidden. Okay, so the implementation details are hidden. That's the abstraction that we have seen from before, right? And then we are going to also talk about what's called polymorphism, which is essentially override. So essentially, you have certain methods that are behaving differently on different objects. Okay, and then you may want to do some overrides for certain methods within classes. So that's what we're also going to talk about. Um, this encapsulation is something not going to be emphasis, but we do have some additional material for you guys to refer to. That's basically saying there, okay, all the attributes and the methods are now sort of like global, right? But certain things you want to make it a little bit more private. So that's the encapsulation. So making things a little bit more privately. Okay, so make certain. So that can be done, but it's just not in a strict privacy way. So it's a little bit harder to obtain. Okay, but still obtainable eventually. But in general, for let's say Python packages and uh, um, libraries, right? So there will be just too many different kinds of classes and methods. So essentially, that kind of privacy is sort of obtained because in general, without a deep digging into the package or library, then you wouldn't really know exactly um, all the possible attributes and methods there are. So, in a sense, once you don't really know the specific name of any attribute or method, then the privacy is sort of attaining in that manner. But well, so the circled topics are going to be the emphasis for today's class. So, all right. So let's quickly look at our example, the car class. So we actually have the initialization, okay? So given these attributes, we realize basically the name of the car is going to be directly populated into self, right? So that's the name. And then we have the attributes of the to identify the car, and then we have the special speed as the attribute that's and whether the car is on or not. But remember, so these are, in a sense, if you think about what we discussed from last time, so you can change the speed, right? But then, even if the car is off, when the self.on attribute is a false, you can still change the speed, so, which is conceptually or physically speaking not possible, right? So those are the things that are certain rules. It's sort of like a text game, or basically the physical rules. Essentially, you're gonna or chemical rules or whatever, or whatever kind of mechanisms that you want to put them in codes. Essentially, you are doing a text game. So it's like a text based game. It's like a board games with all kinds of rules. So that's the limit of OOP. So it's essentially your imagination. So indeed, you can do all kinds of objects and associate with attributes and the define rules, okay, to manipulate the attributes whatever way that you want. So those are the methods. And of course, so this is just like an example that of for one Sky Shark, okay, in a board game. So in a card game. So essentially, there are rules like your current object can partner with another object. So you're gonna eventually define what partner means, okay, and then for that Barling Sky Shark Rider, then it's gonna be another object, okay, and then there was certain rules that's gonna be your strengths, and then how the things are eventually gonna be evaluated, and then how it's gonna affect other objects. So these are all the rules that's essentially going to be coded in syntax. So basically lines of codes. So that's it's really up to how you define things and how you play with things. Okay. All right. To make it a little bit more interesting, so we want to, of course, firstly make sure that the speed only associates to a car that's on. Okay, if the engine is off, then it's not reasonable to assign a speed to it. So here, and instead of getting we did last time the first gear, second gear, right? So here we can do something a little bit more interesting by hitting go fast. Just defining a method that's go fast. So okay, so start the car. So those are, I think those are already established. So go faster, go slower, acceleration, okay, deceleration, and then stop the car. So these are a little bit new, and check speed. Okay, so these are, I think that's modified or added, okay, from the previous code. So what you do here is when the car is on, okay, we can make the car go faster, okay, do acceleration. And each time it's like hitting the acceleration in your car, then you would every time increase the speed by 10 miles per hour, let's say. And then if you want to go slower, you just hit the brake. It's gonna slightly, okay. So it's still, you require the car to be on, and it's gonna every time decrease your speed by 10. And of course, there are certain things you would also want to think about when you think about the physical rules, right? So if the speed is 0, you may also want to further code it so that the speed cannot go below 0, right? So those are the things that you may want to worry about when you think about this kind of methods that's manipulating the speed. Right? So it could go below 0 in your code. So, but at least these are the methods for the speed. And then, of course, you can think about stop, which is like an emergency brake. Basically, when you hit stop, then the car speed directly drops down to 0. Okay, so those are certain things that you can do. And of course, one thing to once again be reminded is that when you are calling the speed, okay, you are sort of aware that your car has an attribute speed, right? But if different people call it in a different way, then you may not know exactly what that attribute name is. So sometimes you may want to provide a method, let's say just check the speed, so that it will just return you a natural language sentence that gives you the data that you want. So the check speed is to return you a string, which is saying, okay, the speed is how much, okay, miles per hour. Also giving the context. And if you want to make it a little bit more related to your object, then you may also want to say something like the speed of which car, okay, is at how much. Okay, so uh, can change to object. Okay, current object. So here we have two cars. My old car, my car. One of them is a minivan. One of them is a Cherokee with different years. So that those cells, I make sure to play with those. And okay, let's talk. Let's play with that. Making the car go faster and slower. So make sure that your syntax, okay, runs as expected. 7, 8. All right. Make sure to run the class. Mm. And I think I mentioned from last time that if you are manipulating and changing your class, you may also want to put your objects along with the code so that whatever changes affected in the memory will directly apply to the objects. And then okay, so let's see. Let's comment out these lines. Okay, so firstly, I want to start the car. And then I wanted to go faster. So originally the speed is 0, and once you start the car, now your car is on, so it can go fast. Let's try without starting the car and see what happens. So initially, wait, we cannot go faster. Okay, so when you go faster, it should return. Yeah, I see. So this cell only prints the last function call. So okay, if you directly go faster as intended in your code, it should be return you sort of like an error message. The car is not on, so it cannot go faster, right? And then the speed, like we just checked, is going to be a 0. Okay, and then we need to start the car and then go faster. And let's see, we should get okay. Now the speed has changed, so there's no output here, and now it should give me a 20, I think. Yeah, right. Okay, so actually it went faster twice, right? So just now I did go faster for once, but it doesn't print anything. And then I check the speed after it go faster again. So basically the variables are in the memory. Okay, so just as a reminder, now the speed is 20, and if you run it again, it will give you 10 more. Okay, so that the speed of my old car has a value of 30 now, right? So we haven't overwritten anything here. So let's then stop and check the speed. Now it's 0. Okay, stop is the method that's giving you sort of like the emergency brake. All right, as expected. Okay, then let's turn it off. Okay, so now indeed the car is off. All right. Right. Mm, any questions about? So yeah, nothing has essentially changed from the methods. But basically, you just we are trying to make it a little bit more reasonable. Uh, but now let's try go slower and could it indeed it's the issue here that you can observe out of the code is that it's possibly giving you some issues for going slower. Okay, my old car go slower, and let me run it for 3 times. So indeed, there are certain behavior that you may want to avoid. Okay, when you are encoding your yeah. So now indeed it's like a negative 30. So one way to interpret it is like okay, I'm going backwards, like back in the car faster and faster. But still, you may want to make it a little bit more reasonable. Okay, per your physical problem. Okay, right. So yeah, so if you don't allow negative speed, then you may want to give some error messages for that design. Okay. All right. Other special methods. So here basically what we want to do is to enable the method of print. Okay, so for a particular object in my class, I'm not really able to print anything reasonable. But here, this is a function. Okay. Well, we still call it a method. A method in our class, which is double underscore str double underscore. This is basically saying what I should return when I try to print my object. Okay, so let's say my car, right? So basically, my car has a number of different attributes, including the make, the model, the color, the year, right? But then when you print it, you want to describe the object in a particular nice way. So that's where this string function would return. And then also I want to enable this comparison. Okay, so for any objects, if I want to give a sort of like an ordering, okay, any comparison between any two objects within my class, then you also want to design the setup a function. This is actually double underscore less than. Okay, so LT just is short for less than. So these are methods that can help you enable the printing something for your object to the screen and enabling the comparison. All right. So now in our class, what we can do here is that just remember this is a docstring. Okay, so this is basically the description of your function, and here it just returns the object's name. So basically, if you call print my car, okay, whatever car that you have, it's gonna print this car is a what color, what year, what make, what else? And this should be this should be the model, okay. And then with like a complete sentence. So sort of like giving a way that's naturally identifying your object. Okay, so and then LT. So double underscore, this is a function. So notice it's a little bit different. So you have a comparison. So this is comparing two things. One is so whenever you say A less than B, you want to identify whether this is a true statement or a false statement. So the left-hand side is going to be the self as an object. The other one is the one on the right-hand side. And how do you determine whether a self is less than other or otherwise? So here we can decide whatever rule that you want. Okay, so basically here we are going to return true if the speed of self is less than the speed of other. So basically saying, okay, if the speed is faster for that car, then that car worth more. Or if there's a tie, let's say they're all off. Okay, they're both off, and then they have speed 0, and then you may want to say that the newer car was more. Okay, so that's basically whatever rule that you want to specify to give this kind of ordering. Okay, so basically this says, okay, if the speed is a tie, then here notice this is a function. This is a less than function, so it always return you a boolean. So you want to return a comparison out of the attributes that you specify. Okay, so this is comparing the left-hand side attribute year, left-hand side year attribute with the right-hand side year attribute. Okay, and then if the speed is not the same, then the larger the speed, the better. Okay. So returning whether the left-hand side speed is less than the right-hand side speed. So if this is true, then it's going to return you a true. Or if your left-hand side has a faster speed, then it's going to return you a false. Okay. So these are existing methods. Okay, within our Python class. Okay, so then we are able to see how it goes. So, okay, still, let me keep it in memory. So I have my car and Jordan's car, and I'm gonna do comparison. So, let's see. So earlier I wrote the str function, okay, the string function. So that tells you what you would print, okay, when my car is within the print operation. So that's this, okay. And then Jordan's car is also basically you see it's putting the color, the year, and the make and the model all within one string, right? So within one sentence, that's basically the way that you define. So, and let me see. I think earlier, okay. So basically, these cars are already off. Okay, so if you're doing the comparison from default values, then the speed are giving you a tie. So you would then see which one is newer. So that's gonna say the Jordan's car is gonna be newer. That's saying this sentence is this comparison is true. But now, as long as you change the speed of my left hand side, okay, if I change the speed of my car to 10, okay, basically you need to turn it on and then go faster. And then in that situation, you my car will worth more. Okay, so let me run that. Okay, so I can also try go slower, but that will not really change much. Okay, so it will give you the same answer from before. So if I let me see, if I go slower, then I need to go slower twice. Let me think. Oh yeah, well when it's tie, okay, when it's tie, it's still gonna return a true. So let me run that. So yeah, so now it's so earlier it was a tie because the speeds are zero, but now if I make it go slower, so it's still gonna preserve the inequality. Okay, so my car is now -10 in the speed, although it doesn't reflect on the screen. Right? And once again, if you print my car, what does it give you? It just give you the predetermined string from your code. So basically, that's a string of a sentence. Okay, putting the attributes within the same sentence. So this car is yeah, color, a year, make and model. Right. So yeah, so let's just make it go faster. So it's giving me something different. Yeah. Any questions so far? So basically, here these are just common methods. Okay, so one of the method here is to enable something to print whenever you print your object, and for the function ls, okay, with double underscores on the left and right, that's gonna give you a way, sort of like the ordering of your objects. Okay, so now we are talking about so that term actually is utilized more often in computer science, but essentially it's going to be overriding. So we're now talking about that term called polymorphism. Okay, so that's overriding. So basically, when you have a superclass, let's say the cars, and you may have some special subclasses of cars that are, let's say, that can speed up faster. So the traditional cars, like just the SUVs, right? Like vans, they will not speed really very fast. But then if you have like sports cars, okay, or some special cars that are designed for running faster, then they may accelerate instead of 10, it's like 20 or 30, okay, miles per hour once you hit go faster. So those are special subclasses. And then for those subclasses, you may want to manipulate the attributes and the methods accordingly. Okay, so that's what's called the inheritance and overriding. So there are attributes from before, like the original color, year, model, and make. So those are going to be inherited. But then there are things that you want to change. Those are the overriding. All right. So here, how do you get that new class, the subclass? It's going to be class. Now, earlier for the car class, it's just going to be car right there. But here, it's going to be the new class, sort of like a function of the old class. Okay. So this is the subclass bracket, okay, round bracket of the superclass. So if I want to define the sports car as a new class, okay, as a subclass, I would just do class sports car bracket car. So that just this syntax just tells the Python interpreter that your sports car is a subclass. Okay, you can say it's a subset of the superset. All right. And then essentially, it has the effect. This code has the effect of making every attribute and method accessible. Okay, in your subclass. Okay, from the superclass. But still, you would have to utilize those attributes and methods. So we're gonna see that in the code. So it's not automatic. So you need to do something to make the inheritance. Okay, and of course, if you want to override, you can still make some changes within the subclass. So to look at the code, so this is what I'm talking about. So you have the sports car as the subclass of the larger class cars, but then still you need to do initialization. But you don't really have to repeat the code. Okay, you can just do car applying the method, okay, from the larger class. Okay, calling the function. So what does it do? Basically, it just does what that initialization in cars does. So remember, in cars, let's go back a little. So the initialization we had earlier have these, right? So basically, for each object, so for each car, it's gonna set the make, the model, the color, the year, the speed, and whether the car is on, off or not. Okay, so all these 6 lines will be executed when you call the initialization in your subclass. All right, so that's what the calling of this function does. So basically, that subclass will make all the things, these functions, okay, the initial function, the string function, the less than function, and these other methods, okay, they are all accessible, okay, they're callable, but you still need to call them, okay. So this line, okay, this line calls the initialization method of the car class. And then in this line, we will be setting up the make, the model, the color, the year, and also whether the sports car is on or off, whether the sports car has the speed is how much. Okay, so those are the things directly inherited. Okay, from this line. Yes.
So our initialization is like nested in the original initialization.
Nested in very good observation. So we are defining the function. Okay, this is the initialization function for my special class. Okay, subclass. But now this is indeed a nested calling of another function. Yes. So yeah, so basically within the function call, I'm gonna call something, some other function. Okay, that's defined earlier. So they are in the car class. All right. So this is the superclass, the name of the superclass. Okay. So that's very important. And of course, if you want to add some new attributes, right? So let's say for the sports car, you may have some other attributes. Well, so later, let's say in the house, okay, in the problem of a house, you will have live coding problems like now it's like a lake house. You would want to have some other features like whether there's a boat that's docked or not. So there are other attributes besides these original ones. So you may also have other variables that then you would also want to initialize within this function, but it's not going to be done from here. But basically, this one tells you for the original attributes how you're going to handle. Okay. And then whatever that you do within the sports car, within the subclass is going to be overriding. Okay. So now the overriding is going to be these methods. So originally, go faster for traditional cars are tens, right? Oh, now it's 50. That's huge. So I think okay, so now basically for the sports cars, they accelerate much faster than the original the supercars. So these are what's called the polymorphism, or we would also prefer to call them just override. Okay, so you change your methods for the subclass. And okay, of course, you can do some special methods that are only specific to your subclass. Okay, but they cannot be called by the original class. Okay, so that's do really I think in English it's just saying the car is running too fast. That's on the back wheel. So that's something that only can be done for these specified subclass. Okay. So basically, this is a method just saying, okay, if you ask the car to do a wheelie, then they will return you a line of text, right? So now that's the logic behind this cell makes sense. So inheritance is basically saying, okay, your subclass can access all the old stuff, but still you need to access them. Okay, so but for initialization, you are doing the calling of the original initialization function. Okay, within your subclass initialization. Okay, that's very important. And of course, for overriding, that's actually really easy. Okay, so that you can just manipulate whatever way that you want. All right, so let's put this in memory also. Okay. And let's okay, so my sports car is now a Mazda Red 2020, and I want to make sure that when I'm doing the comparison, this now works much more because now it speeds up much faster, right? So let me see. Okay, yeah. So let's try making it go faster directly and see if it can be done. Actually, no. Okay, so we still need to just like the older class. So you see, we haven't defined anything. Okay, we haven't defined anything from for making turning the car on or off within this subclass. But the features are the attributes and the methods are already inherited, especially the methods. Okay, so we still need to start the car and then check the speed in a reasonable way. Okay, and you see, we start the car, it's the zero, it's the initial speed, and now go faster is now 50, and now it's the speed, the check speed attribute, or the check speed method can run appropriately. Right. So that's new. And then let's make it do wheelie, and it should be able to do something. Yeah, okay, so that indeed returns that string red wheelie. And also let's see to print my we are still able to call a function, okay, for excuse me for the attribute, the method for my old car. So my car earlier is this Jeep, and can it do really? Actually, cannot. Okay, so because this operation here, okay, this method here only is associated to our subclass, okay, the sports car. So that's the distinction here. Okay. Right. So yeah, let me just keep it like well, it's kind of like a waste of space. Let me think. I want to do a comparison. Okay, so let's what's the speed now? The speed, okay, should be 50. Okay, so let's try uh print. Wait, my sports car less than my car. Okay, let's try that. It's false. Okay, so my car, whatever speed that is, that's less than 50. Okay, so let me think. So the speed here is much faster. Okay, so, originally it's uh, from above it's a 50 for the speed of my car. So in that, that will give me a higher value. Okay, in terms of the comparison. So as expected. All right. All right. So that basically sort of wraps up OOP. So those are the things we would want to emphasize, especially for the topics that we circled. So that capsulation is something a little bit more involved, but the idea you can still read an article that we have a link that we can look at. So right. Here, so in Python, everything is an object, okay, at the runtime. So when we talk about overrides, this is actually something we have seen already. So we have objects, strings, and uh, integers. Okay, so those are the the strings with all kinds of characters and within like a list. But then the integers, they're just integral values. Okay, so now remember the lesson operator behaves rather differently for these two objects. So essentially, this is you can call it the overriding. So for one operator, in the strings, it will compare lexicographic comparison. So when you say a cat and cactus, so when you're trying to compare, you're essentially comparing. Okay, now the first two letter, the first letters are the same. The second letters are the same. The third letter is a T, which is after C. Okay, in the alphabetical order. So that tells you CAC here is uh, has a higher order than CAT, right? So that's the sense of lexicographical ordering. But then for integers, we are actually sort of comparing the value. So indeed, you have different kinds of operations that's done, okay, when you are doing this less than comparison for different objects. So this is sometimes called polymorphism, but also called overriding. They're basically saying, okay, one comparison or one method, it may have different forms in when you're dealing with different objects. And yeah, encapsulation. Yeah, encapsulation. This is a short article that you can read and see how the things are done. Okay, to make methods and attributes a little bit more private. So they are not really perfectly private, but still, it gives a little bit privacy. Right. Um, So any questions so far? So yeah, well, so make sure to, so basically up to this point, we do have a relatively good idea of what the objects are, what the attributes are, and what the methods are. So and also basically we have talked about abstraction. So those are the method, those are tricks that you do, okay, when you try to hide certain implementation details from the well method users. Okay, so and then we have this kind of superclass, subclass, this inheritance, and also we can make things a little bit more specific by in subclasses by overriding. So these are really important and basic concepts and ideas, okay, from OOP that we will utilize when we get into introductions of future packages. But now here we are able to talk a little bit about the data types and data structure. So, in general, well, in the computer science course, so wait, let me think. Mm, so we have seen actually the strings, lists, tuples, sets, and dictionaries. Those are really fundamental data types within Python. But then here we can customize one class. Okay, a class is also a data type. And basically, whenever you talk about an abstract data type, you're saying, okay, the high level is going to be some data type, but then you care about certain attributes, and then you would need to do some manipulations. Okay, those are the methods in the data type. So those are the key features, okay, of an abstract data type. But then there are other related topics. So data types is one thing, okay? Data structure is another thing. So a data structure is going to be a prescription of how to structure your data. So, so yeah, well, this text I would say you can pretty much read it on your own. But basically, what's the idea here? The idea here is that there are efficient ways for you to sort of structure your data. Okay, so to store your data in a nice way and manipulate your data in a nice way. So there are certain tasks that if you handle your data in a special way, then other processes will become faster. Um, so, and well, in computer science courses, these topics are going to be discussed in more details. So today, what we're going to talk about, well, in this section, is going to be stacks, queues. So for hash tables, that's a very important topic. Okay, so remember when I talk about lead code, right? So in lead code, there are many small tasks that you can use for loops, but they will not be super computationally efficient. They will be each iteration efficient. So the memory cost may be small for each iteration, but the procedure runs, right? So if you want to speed up that kind of process, hash table is one of the most important choices that you can utilize. But that's something not going to be emphasized for this course. For like binary trees, that's also a way that you can structure your data so that essentially uh, you need to uh, so if the thing is all in one line, going through the list is gonna be in the size of your data, right? But if you sort of like do the the binary tree, then the depth is gonna be in terms of a log, which is a little bit more efficient. So so certain data structure are essentially efficient ways to deal with the data. Okay, with respect to what kind of tasks that you are looking at. But for stacks and queues, they are super intuitive. Okay, so we're gonna talk about these ways to manipulate data. Okay, so basically storing data in a really simple way, and just getting hold of data is also gonna be done really efficiently, and it's gonna be helpful. Okay, in certain tasks. So stacks. So if you think about the term stacks, it's sort of related to a concept that's called a stack frame. So in Python, okay, the memories are going to be well, we have the global frame, the stack frame. So this word stacks here is a little bit different. So in terms of the stacks, this is actually, you can think about it as a dynamic version of a list. It can be implemented using the list data type. But this is not exactly a list in the sense that this is a high level idea. So the idea is that it's like a stack of paper. So let's just think about this stack of paper as the data that I'm handling. But about the stack of paper is that you are not really able to directly get your the piece of paper that you want out of the deck. What you can do here is to always look at the top of the page, and if you get new data into the stack, it's going to be always on the top. Okay, it's the there's a term that's really somewhere, yeah, it's the last in first out. Okay, so whenever you have new data into the stack, it's going to be the first one that's coming out. And then if you want to get something deep into into your stack, then you would need to do it one at a time. Okay, you cannot really extract data directly out of the middle. So that's something special. And the stacks, they are essentially really handful, useful if you would want to sort of like redo your certain procedure. Because let's say you have new data put in, okay, and you want to directly remove it. So that's something you can directly do. And if you think about your computational programs or editors, so this kind of operation is always doable, right? So basically, whatever edits that you do to a file, and you want to redo and redo all the way back. So this is kind of like a stack data structure in your memory, so that you can always redo. So that's the idea of the stack. So you cannot really extract data out of the middle. Okay, so you can only deal with the one of you can say the last of your string. Excuse me, of your list. For every new data, you're gonna put it at the end of your list, and then for if you want to extract data, you can only get the one at the end of your list. All right, so that's the what's called the last in first out policy. So to imagine, let's say we want to reverse a string. So earlier when we do the recursion, what we can do here is, okay, you have a string, you put your first element at the end, and then for the rest of the things, you're gonna do recursion. But here, unfortunately, you can only take the last element out, put it in another stack, and do it really systematic way. So every time you put the last element, pull that last element out and stack into the other, yeah.
So is a stack like mathematically ordered, or like can we reorder it if we want to, or is it fixed?
So yeah, very good question. So it's always going to be ordered. So a stack is, if you think about it in the mathematical sense, it's going to be A1 up to AN. However, the thing here is that AN is the last element. That's the only one that you can play with. And then you can, so this is the last in with the AN that can be first out. So if you, so here, this is why we're talking about the reverse. So if you want to reverse, it's going to be AN first and then AN minus one and then all the way up to A1, right? But then what you can do here is only to take AN out and then put it in the new stack. And then you can deal with the second last, which now is the last, and then you could put it in the next one. So yeah, yeah, indeed. When you think about the pile, like a stack of paper, is the same idea, right? You do have a ordering. You cannot really extract the things directly out in the middle. So that's sort of like natural when you think about like redoing things in editing your file. Yeah.
So it takes more time, but it saves more memory. Is that kind of the whole purpose of the stack?
Well, if you are saying I'm extracting data from the middle, then yes.
Okay.
So yeah, it's immediate if you want to do redo.
Yep.
Yeah, but
But
then if you want to go further, then it's a little bit more expensive. Yeah.
Okay.
So yeah, there are, let me see. So yeah, there's a distinction. Okay, so that's the comparison right here. So the queues and stacks are different in the sense that insert and deletion only can happen on the end. So that's my sequence, A1 all the way down to, let's say, AN. So if you have the new data, you can only push at the end, and then you can read what the last data is, and you can throw it away. But then you cannot really do that to the things before. Okay, so only the last one is sort of manipulable in the stack. So basically, like the first piece on your stack of paper. Okay, but then the queue is different. Queue is that it's like just like a line that we standing, so waiting for some like the bank counter to serve. So it's going to be first in, first out. So basically, it's going to be well, let me think. So that's going to be the front. So now this it's kind of not so natural. So it's A1, A2 all the way down to AN. So now if you want to put in new data, it's going to be AN plus one into the sequence. Okay, you can read what that is, but then if you want to take it out, you can only take out A1. So that's basically the first come first serve. So the ones before they will be handled first, okay, but then the new data will be stacked at the end. Cool. So in I think an earlier version of this course is that for the remainder of this section, we are going to utilize the data structure of a list to mimic a stack, which is not really difficult. So basically, the high level idea is that it's going to be last in first out. So make sure that you're able to manipulate the last piece of data within the stack, then within your list, then fine. But then an earlier version of the course also asks you to sort of put the queue, this concept in syntax. So what you can do is you can read the rear end of the queue. You can read the front end of the queue. You can get in new data at the end of the queue. But then if you want to execute, you can only execute the first term in the queue. So that's also something we can implement using the data structure as a list in Python. But yeah, these are in the data structure here. They are essentially efficient ways that are appropriate for certain applications. So there are applications, essentially, like let's say you have an order of execution, right? So then you would want to do a queue. So new data comes at the end of the queue, but then the old data will be firstly executed. So let's say yeah, one natural scenario I can think about for using queues is like a stochastic gradient descent. So you have a lot of gradients that can be computed, and on each gradient you are updating the model parameter, right? So the old gradient information should be processed first, and then the new data will just come along, basically stacking all the way on the left hand side. Okay, so that's the idea there. Okay, so sometimes the gradients are arriving faster than the speed of your updates. All right. So when you are processing updates, so that's where you would need to maintain this kind of a queue. Right? And one thing I'm kind of thinking is that although the things are ordered, but on a high level, let me scroll back a little. Just in stacks and queues, the indices actually they don't really matter. So you're only looking at the beginning of your queue, the end of the queue, or just the end of your stack, and then you're only manipulating the last one. Okay, so of course, when you're having a list in Python, then there's always going to be indexing. But then the indexing is not really essential because if you think about the queue, it's going to be A1, A2, all the way, let's say, to A10, right? But then if you remove A1, then your A2 becomes your new A1. So it's kind of like the indices are sort of like shifted. But essentially, the indices they do not really play an important role in the data structure. So it's always the first one is going to be moved out. The last one is going to be kicked in. So in that sense.
What is there a practical case to use that? It's like I understand you, but that
Yeah,
ranking on.
yeah, that's so yeah, well, I would say practically speaking, I cannot really think about a way on the top of my head, but what I thought about was what I mentioned, just like when you're editing your file. So you can do a sequence of redos. So that's essentially a stack.
Okay.
Yeah.
So just
But then if
typing something in.
yeah, type in that yeah, whatever edits that you do. So let's because I'm using OneNote a lot, right? So when I'm striking undo, just removing the last uh, handwritings that I have done on the screen, then so that's essentially a stack.
Okay.
Yeah. But then, yeah, then there are certain things that okay, if you go back a little and then you change something in the middle, then you can not go further. That's something also special in the modern editors that's not 100% stack. So yeah, there should be ways. So let me see if there were discussions right here. Probably. Yeah, well, I'll think about it and get back to you because there were discussions about what kind of applications will utilize this kind of data structure. But currently, I don't have it in my on the top of my head.
Would one be like an exam format where you can't move back to previous questions and you can't move forward until you insert the current question? Would that, in theory, be coded with a stack? That data structure to create that? 'Cause that's the only thing I can think of.
Yeah, yeah, that's a reasonable scenario. So there's certain like online application procedure or like exam procedure that you need to finish the current stage and save and then move on to the other stages and going back to earlier stages. But yeah, that's yeah, but yeah, I think I've read somewhere about a more realistic application, but I currently just couldn't think about it. Uh, okay, so what else? Okay, so these are the methods. So let's so basically we're looking at the lists S and X. So we only append at the end. Okay. And then if you pop, essentially you're gonna just remove the last element. So yeah, on high level, these are the methods that you can do. But later, yeah, next time we're gonna define a class that's called a stack. So within that class, you're only allowed to do these manipulations of data. Okay, and then of course you can check the last in your data structure. Okay. But I would say the emphasis on the quiz will be mostly on the OOP stuff. All right, so let me end the recording.